Welcome to Not Factory Approved. Today's video I'm going to take this old buzz box AC welder and add a DC function, and I'll show you how I do that. I'm fortunate in that this welder has an isolated transformer. It doesn't use an auto transformer like some do, and I'm also fortunate in my past work I scrounged up some very high power diodes that were of no use to us in the work, but had come out of equipment that we had stripped. I definitely was not going to throw those away, so I kept them. And while they're much more powerful than I need, this one is 350 amps. Likewise, same thing, 350 amps DC, and these are 450, I think. Over 400 anyway. And they certainly can take the voltage. So I'm going to put those into this welder, and then I will have a reversible or positive polarity DC, depending on how it's plugged in. In order to get the diodes in the proper polarity and isolation, I'm taking this piece of aluminum, which has isolated mounts on it. I'm cutting it in half. And I'll show you why I'm doing that on a circuit diagram. So here's the diodes. I'm going to make what's called a bridge rectifier. For those of you that don't know electronics, I'll show you what that means in a minute. These are the high power ones, but it's going to be basically one side, since this has the anode or positive terminal attached to the heatsink, and this has the negative terminal, cathode, attached to the heatsink. So they have to be isolated, and in a bridge rectifier you can't have them all four tied together or it's a dead short. So there's the start, and I will find a spot in the chassis where these can mount, and then these will tie together, form legs of the bridge, and this I'll groove and put it in there so that it keeps the two of them isolated from each other, and then allows them to mount on the chassis of the welder and be semi-rigid. There's the plan so far. Teflon 1/2 inch square. I ran it down in between. I cut grooves with just a metal cutting disc on a small 4.5 inch grinder, and then the same thing. The back piece is just a short section that's grooved, slides in between. So the idea being that once I mount this on the cabinet, I'll make the holes so that I can squeeze it together and tighten it up. Now, if you know electronics, then just bear with me or skip ahead. But here's what goes on. We have a power plug, the ground. I'm just going to draw the ground that way for now. And then, so this would be the hot, and it's 220, so it's really two hots. 50 amp circuit is what it's tied into. Those two go to a transformer. This is the electronic symbol for a transformer. Or what, coil. That part, if you add that, that's an iron core, and then you do the secondary. I'm drawing it bigger, and I'll show you why in a minute. So the power switch is in here, and it breaks both lines. So I didn't draw that in, but I'm not going to be doing anything with that. So there's the transformer. Then we have the high side, and we have the ground side. That's the way they label it. And this is the low. So there's high output, low output, and ground. I don't know for sure, but I'm thinking this is center tapped, which means it's in the middle. And I could use that for DC with two diodes, but I would have a lower voltage and lower current. So I might have to do that in the future, but for now I'm going to tie these. So we have this going outside the chassis of the welder. There's 2 outlets there, 3 actually, labeled high, low, and ground. So now I'm going to take this, I'm going to take the high and run it to another outlet. Those are connections. So now this is a bridge rectifier. It has anode there, cathode there, make sure I'm doing this right. Sometimes I forget. Sorry, that's backwards. Those are diodes. And we have this one here. And this.
Got stakes for now.
Okay.
I'll just leave them out here.
Sure. Thank you. So this is the diode, the 4 rectifiers, which are on that block over there. The 2 big ones have a common anode that's tying to the heat sink or frame that it's mounted to. And the other ones have a common cathode. This is the cathode, this is the anode. So then you have an output from there, and I'll put another jack on the front of the machine, and this will be positive output, this will be negative output. So depending where you plug the cables in, you either get reverse polarity or positive polarity. And that's it. So this will be, 2 of them have common anode, and 2 of the diodes have common cathode. So this is how it will be. These 2 will be the common cathode, these 2 are the common anode. And that's the way I'll wire it up. Hopefully it works. Let the disassembly begin. Okay, cover's off. Here's what it looks like inside. The white case is the fan. See the transformer down below. 2 windings. This is the adjustable portion for the current delivered. Just changing the position of the magnet within the core. Here's the 2 outlet terminals. 3 if you count the ground down there. There's a power switch. It breaks both lines. And power coming in. So I will be tapping into this and going across and trying to find a place to put that board. Might be down on the bottom. It seems to be the most room. I assumed, yee-haw, as the saying goes, that I could put those 2 panels together and mount them up near the top. Well, there's no room at all up there. In fact, it doesn't fit down below either. So to make it easier, to make sure I don't make a mistake, I've labeled each diode, and then I've put corresponding marks on the schematic that I've drawn. And then I'm using the old battery cable from a GM van. So I've bolted that together with a short bolt. Make sure it's in tight. I'll probably just tape over that. I don't have hose at the moment that's big enough to go over that. And then I will cut the cable, and I'll have to get some more of these connectors. And those ones are too big for this wire, so it'll have to be smaller, and then I'll have to make the holes bigger because they will have to attach up here to those terminals and to the terminals that I will put in the front, possibly down here. Maybe crossways. So there's more room. Sometimes it's easy to get confused, but right now I'm going to show the connection between D3 and D4. So D3 cathode, which is this one, connects to D4, this one, anode. If you can see the symbol there, not sure, but this is anode, that's cathode on this diode. And on this one, this is cathode, or sorry, this is anode and this is cathode. So I've joined them together with the battery cable, taped it up. I've used a 3/8 coarse bolt and nut, new ones. Tighten them up as much as I can, as much as I dare. And then this will come up with a new terminal to the ground connection on the transformer. And then I'll use the other piece of wire to connect the other side. Here's the new jack that I'm putting in. I have two of them. I bought them many years ago. It's taken me a while to get to this project. So it looks like, I believe you can get them from a welding supply. I'll look inside. I'm not sure what company made these. They're not putting any logos there at the moment. The other problem I have is that I made assumptions again. I assumed that this was going to fit underneath the transformer, forgetting that the core has to slide down. So at maximum power, that's where the core is. So I'm not likely to ever need this at 300 amps, but I would like it to be capable of going as high as possible without worrying about shorting out the diode connection. So I'm reevaluating how I'm going to put these in. There's a little more room on the other side than there is here. I've cut down one of these, this one, so it's shorter, closer to the diodes, and that clears the transformer. So we'll see if I want to put this in upside down, right side up, or how I can mount these so that they're not ever going to interfere. I'll try this one now. I think it'll fit in there. To make a standoff yet for here, going to the back panel. The back panel of the welder will be there. This will be in here. I can space it evenly so there's no shorts. And hopefully that will fit, and I'll have enough wire left. Please check back for episode B, part 2 of converting an arc welder AC to DC. Please don't forget to like, share, subscribe, or even notify, or any of the above, or all of the above. Thank you.